So this is 13.16. Indicate the principal type of solute-solvent interaction in each of the following solutions and rank them from the weakest to strongest solute-solvent interactions. So there are four types of solvent-solute interactions, and they're intermolecular forces. So there'd be London dispersion forces holding the two molecules together when they dissolve. Secondly, there would be dipole-dipole forces that hold two molecules together, two polar molecules. Thirdly, would be a special case of dipole-dipole, and that would be when there's hydrogen bonds between the two molecules. And lastly, there would be ion-dipole interaction, and that would be where you have a charged particle, positive or negative, usually a metal or a non-metal, an ionic compound that's dissolving, with a dipole, something like water, something that has a dipole moment in it. And this is listed usually, depending on the size of the molecule, from weakest to strongest. And so when we look at each one of these, look for these types of forces in each one. And then when you identify the forces in them, you know those are the solute-solvent interactions for each one. And to help you identify the type, I always recommend first drawing a sketch of the Lewis dot structure. So KCl in water, so water is HOH like this, and you can see that there is an H connected to an FO or N, and so this is going to have hydrogen bonding capabilities. And then it says KCl in water, and KCl would break up into K plus and then Cl minus. The plus right here would be attracted to the negative end of the dipole moment of the water, so there would be a ion-dipole interaction going on there. And then over here, if we were looking at another water molecule orientated this way, there'd be a positive end to it right here, and that would attract to the negative Cl minus, another ion-dipole interaction. So ion-dipole for letter A. Letter B, CH2Cl2 in benzene. So CHHClCl might have a little polarity to it, but not a lot. And then benzene, of course, is the ring structure that has a zero dipole moment and a rotating double bond that goes around, three rotating double bonds that go around, and this is nonpolar. And so this guy would have some London dispersion forces, this guy would have some London dispersion forces, and that would be about it, since they're both nonpolar. That's the only things that would hold them together. Methanol in water, so methanol, CH3, and then we have an O with an H right here, and so we're going to have an H connected to an FO or N, so we have a dipole moment going in this direction right here for a negative charge on the oxygen, a positive charge on the hydrogen. And then it's in water, so we have H2O with once again a negative charge over here by the oxygen and a positive charge by the hydrogen. And this would be a hydrogen bonding interaction right here between those two molecules. So if we had to rank them then, we would rank B as our weakest, because it only has London dispersion forces right here. We would probably rank C as our next weakest, or in the middle, because it has hydrogen bonding forces. And then our strongest interaction would be the ion dipole here in letter A.